So 5, 4 is a continuation of logs and exponential. Now the difference is we get an equal sign. We've done a couple of these already. We've done it where they're 1 to 1 and we just set, like, have the bases be the same. So we set the exponents equal to each other, or the logs on either side of the equation. So we set what's next to it equal to each other. So a lot of that's the same. But obviously we start to bring in some different stuff. The good thing is we're going to continue to practice logs and exponential. The bad thing is they definitely get more complicated. So we kind of grouped it by exponential and by log. So the first kinds of equations are all exponential, and we know they're exponential because they have something raised to a power, and it doesn't have the word log in it. That's how you know it's exponential, okay? So there's 3 different kinds. One is what we've already done, which is if we can change the base to be the same. So if we could change it so that it's like a 2 to the x equals 2 to the x plus 3, something like, or 3x plus 3, something like that, where the base can be the same and we just ignore the base and we set the exponents equal to each other. So that's the 1-to-1 property. The second type is if e is on one side of the equation, you want to take the natural log of both sides of the equation to eliminate the e. So we are going to make ln a verb. We are going to ln both sides of the equation. So if I have something like e to the x equals 2, in order to solve that, we ln both sides of the equation, and I'd get ln of e to the x equals ln of 2. What is ln e to the x? Just x. So it cancels out and I get x equals ln 2. Without a calculator, my answer stays like that. With a calculator, I literally type ln of 2 in my calculator. And I get, most of these answers say round to 3. So it's 0.693. So if I have a single e on one side of my equation, sometimes I have to isolate it first, so sometimes I'm going to have to work, you're going to see that in a minute, work to get e by itself. But then we, like I said, we're going to start to make ln a verb because ln is the inverse of e. We ln both sides of the equation. The ln of e is going to cancel out, leaving you with just the exponent, and then we solve from there. The last kind, and this is the one that tends to be the most complicated, is if the bases on both sides of the equal sign cannot be changed to be the same number. So if I had something like 2 to the x equals 3 to the x plus 4, there is no way to change 2 or 3 to have the other one as its base. So we do the same thing. We ln both sides of these equations. I'd get ln of 2 to the x equals ln 3 to the x plus 4. I'm not going to walk all the way through this, but you'll see in a moment. I bump this to the front, and then I have to work to solve for x by itself. Those are the hardest of them. You'll know when we get there, okay? Because the process is a little bit longer. But that's the third kind, if the base can't be changed to be the same.
What do you mean if the base can't be changed to be the same?
Like, can I find a number that I can raise to a power with 2 and 3 to get them to be the same base? It's not, right? It's not like 2 and 8. Like 2 and 8 I can make 2 and 2 to the third, right?
Yeah.
So if one is not a power of the other, then we have to do it this way.
Okay, thank you.
You're welcome. All right, so these will all say just solve for x, and on website and then also on your test, you're going to round it to 3 decimal places. So if you want to get in the habit of that. If it's not a perfect whole number, obviously. So what's happening here? It's 1-to-1 because the bases are the same, right? So I can ignore the e and I can set negative x squared equal to negative 3x minus 4. And then what? I'm going to have to move the x squared because I'm going to have to factor this, right? 0 equals x squared minus 3x minus 4. As soon as you see an x squared and an x, realize you're going to end up factoring. Now find the factors of negative 4 that sum to negative 3. X minus 4, x plus 1, and then split and solve this. X would equal 4, and x would equal negative 1. That did not require a calculator. Something like that would be on Wednesday's portion. So my answers are -1 and 4. And on the test, you'd enter it in just like that. No spaces, no x equals, just the -1 and the 4. You do too. Again, 1 to 1. Hi. All right, you still got -2, 4? Yes, good? Okay. So that's when it's 1 to 1. It would have been the same thing if the exponent, if the base was something other than e, as long as they're both the same, right? That's 1 to 1. Okay, this one, oh, I didn't have a, yeah. This is actually 3, and then 3 is part of the equation. So before I can even mess with the base on here, I have to get the exponent on the side by itself, or the base with the exponential, so the exponential base. So the first thing I'm going to do is actually get rid of this 3. So I'm going to divide both sides by 3, and I get 2 to the x equals 14. Can I change 14 to be to the power of something? No. So this is where our ln comes into play. So I'm going to ln both sides of these equations, and I get ln of 2 to the x equals ln of 14. Now, ln of e would cancel out, and I would get just the x, but ln of 2 does not cancel out, right? But the exponent here does get bumped to the front, so I get x times ln of 2 equals ln of 14. And then how do I get x by itself? Divide both sides by ln of 2. So without a calculator, it would stay like that, but with the calculator, which this would be on the calculator portion. And you'll know on the homework because it'll say it around. This would be ln 14. You have to close those parentheses. Remember, you got to be careful. Divided by ln of 2.
So this one's the calculator part.
Yeah, this would be a calculator part. 807. So that's what's hard is they're like that. It's not like a topic and a topic. They're going to be blended in together.
Wait, so if we didn't have a calculator, what would the answer be?
It would be ln of 14 over ln of 2.
Okay.
Yeah.
When you plug it into the calculator, you just need to plug in the ln of 14 over ln of 2.
Yeah, but you got to be careful because it'll open the parentheses here. You got to make sure you close them here and then do the divided by. All right, you try 4. All right, so again, we divide both sides by 2 so that just the exponential expression is by itself. Then you want to ln both sides of the equation, and then the x bumps to the front. X times ln of 5 equals ln of 16. Divide both sides by ln of 5, and I get x equals ln of 16 over ln of 5, which approximates to 1.723. We good so far? Yeah? All right, now just a couple more steps. Because I got to get e, oh, sorry, Sophia.
Sorry, when I put it in the calculator, it didn't.
E is not on the side by itself. There's only one e, so this is not a 1 to 1 because there's not an e on both sides of the equation. I got to bump the 5 to the other side, and by doing that I mean subtract 5. And I get e to the x equals 55. And then I get to a point in which I can't change these to be the same base, so I have to ln. So I'm going to ln both sides of my equation, and I get ln of e to the x equals ln of 55. And then ln of e to the x becomes what? Just x. And x equals ln of 55. So if this were, which it won't be, but let's just say if this was on a portion of a test that was non-calculator, your answer could be left as ln of 55. It's not going to be that. This would be on the calculator portion. So x is going to be approximately 4.007. Okay, you do 6. How did we get 3.401? We good? Yeah? Okay. All right, now what?
Do you add 4 with
Yep,
this, or do you
add
divide
the 4. You're good. So you could divide by 2, but if you divide by 2, you have to divide this, this, and this by 2. So I would say move the 4 first. 2, 3 to the 2x minus 5 equals 15. Then divide by 2.
Minus is plus.
Yeah? Okay, okay. Mm-hmm. All right, this equals 15 over 2. Now that's like a number that terminates. So if I wanted to make that 7.5, I could. You could also leave it as 15 over 2. What you don't want to do, if that's something like 15 divided by 3, no, that's the bad example because that actually goes evenly. 16 divided by 3, you don't want to use that and round it. You want to keep these things exact as long as you possibly can. Does that make sense? So this one is different because that terminates and that's an easy decimal. You could make that 7.5. Or you leave it as 15 over 2. But if you do not want to round until the last possible time that you can. So I'm going to leave it as it is so we can kind of like practice that process. I'm going to leave it as it is for now. And then what would be the next step? ln both sides of the equation because I cannot change these to be the same base. So I get ln of 3 to the 2x minus 5 equals ln of 15 over 2. Oh, that color is really hard to see. This bumps to the front. 2x minus 5 times the ln of 3 equals ln of 15 over 2. Now what? Divide by ln of 3. 2x minus 5 equals ln of 15 over 2 over ln of 3. Then what? Add 5. Yeah, it gets messy real fast. So I get 2x. I'm going to leave this whole thing just the way that it is so that we could see what's happening. And then what's the last step?
Do you divide by 2?
Divide by 2. So x equals ln of 15 over 2 over ln of 3 plus 5 all divided by 2. And now we let the calculator do the work. So be careful how you type this in. ln of 15 divided by 2 divided by ln of 3. This is like 1.834, but I'm not going to round it. I just want, like, just check your work at that point. Add the 5, 6.834, and then at the end, divide it by 2. But keep it exact in your calculator. And I get 3.417.
Do you like,
You have,
you put it all at the,
so say that again.
do you put it all at the same time? Or like,
You don't need to. So I did ln of 15 over 2. I'll turn this one on. ln 15 divided by 2. Hit enter. Divide that by ln of 3. Hit enter again. That's that 1.834. Add 5. Hit enter again. Then divide by 2.
Thank you.
You're welcome. So I can't stress enough how important it is to be practicing this on the calculator you intend to use next week. One, this is super hard to do. I will give you the lockdown calculator, but that's like as basic as your iPhone one, and so you have to do everything in the reverse order, and that's really hard. So you want to either have a scientific calculator or a graphing calculator that you are comfortable with using to do these kinds of things, because these kinds of things are going to be on your test. You good?
Yeah.
Yeah.
I'm just like, okay, yeah.
We're gonna do another one. Oh, this parentheses should be big like that. All right, so I subtracted 4 from both sides. 6 times 2 to the x plus 5 would equal 7. I divided both sides by 6. So I get 2 to the x plus 5 equals 7 6. They're not the same base, so I ln both sides of the equation. I get ln of 2 to the x plus 5 equals ln of the 7 6. Bump the x plus 5 to the front, so it's x plus 5 times ln of 2 equals ln of 7 6. So that's a perfect example. You don't want to round that to a decimal, because it's not an exact decimal, so you want to keep it as 7 6. Divide both sides by ln of 2. That then cancels out from the left. I get x plus 5 equals ln of 7 over 6 divided by ln of 2. And then the last step is to subtract the 5 from both sides, and I get x equals negative 4.7776. So that bumps to negative 4.778. Still good? Mm-hmm.
Wait, so what was ln 7 over 6 divided by ln? What did you get?
ln 7 divided by 6 divided by ln of 2. 0.22239.
And then you would subtract it.
And then I subtracted 5. I think this is our last round of. Yep. Okay. So 9. 3 to the 2x minus 1 equals 0.4 to the x plus 2. So the base got messy because it's a decimal, but it's the exact same thing, right? There's still two bases that can't be changed to be the same. So I'm going to do what? ln both sides. So ln, and I get ln 3 to the 2x minus 1 equals ln 0.4 to the x plus 2. Exponents get bumped to the front. So 2x minus 1 times ln of 3 equals x plus 2 times ln 0.4. Now here's where it gets messy. There's an x on both sides of these equations, right? So I can divide both sides by ln of 3. So this one's gone, and I get 2x minus 1 equals. This is still going to be x plus 2 times, and it doesn't matter which one of those gets the denominator, so I can make this ln 0.4 over ln of 3. But dividing by that x plus 2 is not going to solve it. It's just going to keep moving it back and forth. So if you've got x's on both sides and they're part of both products, I actually have to distribute this to both terms here. So I'm going to get 2x minus 1 equals ln 0.4 over ln 3 times x plus 2 times ln 0.4 over ln 3. Because if I, naturally, what you would think to do is divide both sides by x plus 2, right? But then it's just going to come over here, and I still have a variable in the top and the bottom. So my solution to that is to multiply it back out. So it doesn't work. It keeps bouncing back and forth. So you've got to distribute, when you have x on both sides of the equation sides like this, an expression, not just x, but an expression on both sides, I'm going to distribute. I'm going to group together the ones that have x and then the ones that don't. So I'm going to move this. Let me change this color. It's super hard to see. I'm gonna move this to be on the side with the 2x, and I'm gonna move the negative 1 to be on the side with that yucky fraction, because neither of them have an x. So I'm gonna group my x's